welcome to Introduction to Aerodynamic Objects Tutorial 2, my first aerodynamic object. And in this tutorial I'm going to make some shapes that have aerodynamic drag, let them move with the wind, and then build a tower of boxes that we can blow down. Firstly, we're going to set up a scene with some prefab assets and a uniform flow. Then we're going to create an aerodynamic object in the shape of a sphere and add wind and force arrows. Then we're going to vary the wind speed and direction, see what it does. Then we're going to try something different, build another aerodynamic object, this time a Q-shaped one, using a create menu. And also this time we're going to drop it to see how it behaves rather than blow wind at it. Then we're going to build a tower out of those boxes and blow it down. This is a scene diagram for the tutorial, the first part we're going to build. So we're going to build this object here, so it's going to be a sphere, it's going to have a drag arrow on a wind arrow on it, and it's going to have a rigid body on board so that when we blow the wind on it, it should roll across the scene. So we've got a uniform flow component in there, which we saw in the first tutorial, working with wind speed, direction and turbulence. But then these things over here is our aerodynamic object, and this is a composite object in the sense that we've got a number of game objects that have been parented together, and this is a kind of a base way of doing it, but it's good when you start doing this in the sense you can put different components on different objects and you can see what's going on. So at the top of the hierarchy here we've got our rigid body dynamics, so our object here has got a rigid body on it. Next down in the hierarchy we've got our geometry, so this is controlling our shape. We've also got a collider on there, which is giving us our physics interaction with the terrain. And then at the bottom of the hierarchy, we've got our aerodynamic object. And so this is where the aerodynamics is, the flow physics. And for this example, we've just got a drag model on there. And then for this object, we've got some visualization components. So we've got a wind arrow and a drag arrow. So here we are in Unity. I've created a new scene, tutorial 2 work in progress, and to start with we are going to drop some prefabs in the world. So we need a ground plane, going to drag that in, and we need Aeroman in there for our scale, drop him in. So that's our basic world. Now let's add some wind. So we're going to use a uniform flow fluid primitive as we did before. So I'm going to use the create menu for this, aerodynamic objects, flow primitives, uniform flow. So that's gone in there, and we can leave all these settings as they are. Next up, let's put some field visualization in there so we can check what the wind is doing. You can't see wind until you visualize it. So I'm going to go to aerodynamic objects, flow visualization, and then field arrows, and they by default come in at a scale of 1, but let's increase that to 10 meters by 10 meters, and we need to offset it by 5 meters so it's sitting above the world on top of the ground. We go, that looks okay. So we've got our man in the middle and we've got a 10 by 10 box round it, 3 by 3 arrows, and let's just test to make sure that works. I'm going to get my uniform flow locked into this inspector window so I can control it. Okay, that's good. So that's what we would expect from what we saw in tutorial 1. And because we're going to be blowing pretty hard in this scene, I am going to reduce the strength or the scale of the arrows. So I'm going to reduce it by a factor of 5, just so that we can push the wind speed up and they don't fill the space too much. Great. Okay, so I did that in play mode, so that's no good. Come out of play mode, do it again. Okay, let's create our first aerodynamic object. So what I'm going to do is right click and do create empty. This is our first game object at the top of the hierarchy, and we're going to give it a name. We're going to call it sphere aero object. And at the top, if you remember, we are going to put our rigid body. That's always good practice in Unity models to put the rigid body at the top of the hierarchy. So I'm going to do add components, start searching for rigid body. There it is, mass of 1, that's fine. Drag 0, angular drag. So this is the Unity drag model, so we're going to turn all those off. We can leave all those things the same for now. Next down in our hierarchy, we want to add the geometry, and we're going to do this via a standard sphere in Unity. So I'm going to rename that to sphere geometry just to make it clear. That's where we're creating the geometry for our object. So the sphere has appeared. Clicking back on the top of the hierarchy, I'm going to lift that up and move it out of the way. And when we've added this sphere, it's also added a sphere collider automatically. So this is handling the physics of this sphere interacting with the plane, which has got a collider on it. So when we let the physics engine do its rigid body dynamics, this sphere will land on the plane and roll along it because it's got a sphere collider acting on it. Okay. So now the magic, so we need to add some aerodynamics. So what I'm going to do is right click, create empty, and we're going to call that aerodynamics. And the component we want to add here is Aero Object. And this is where you access all the physics for generating things like drag and lift and buoyancy through this Aerodynamic Object component. And you might have noticed that this dark blue mesh appeared on the sphere. So this is the kind of the gizmo to show you that it's now got an aerodynamic object, and this mesh is the kind of geometry that's used for the aerodynamics. We're not doing computational fluid dynamics on it, but we're using that mesh, the basis of its shape and cross-sectional area and the overall size of it to work out what the drag is from kind of first principle aerodynamics. So for this tutorial, we're just going to have drag. And the other really important thing we need to do is assign a rigid body. So at the moment, this aero body will produce forces, but it doesn't know where to apply them. So what we're going to do is tell it that to apply the forces to the rigid body at the top of the hierarchy. And it works in both directions as well, so this aero body also uses this rigid body to get its velocity. So when it's moving through the world, it's obtaining its velocity from this rigid body. A couple of other things on here. In terms of reference area, we'll see when we do a cube, you can change this, but one of the things that you need for a drag model and lift model is a reference area to work on, and it's basically the size. So we're using an ellipse because we're using a circular body there, that's fine. And pretty much we can leave all those things as they are. Okay, so on its own that would produce some forces, but it's quite hard to see what's going on without visualizing them. So what we're going to do is add some visualization components for that. And so what we're going to do is add a drag arrow. And it's going to be red, and they start right at the middle. So if we want the arrowhead to start on the edge of the sphere is 0.5 meters in radius. So I'm going to add an offset of 0.5. And we'll see these when we press play. And I'm also going to add a wind arrow. And the wind arrow comes from the other side, so I need an offset of minus 0.5 on that. Okay, and I think we're good. So we've set up our uniform flow, we've checked that it's working with our flow field arrows, we've created our object, we've got our rigid body at the top, we've got our geometry defined here, we've got our aerodynamic object here, we've told it that the forces should be applied to this rigid body at the top, and we get our velocities from there, so we're all good. Before we let it go, I'm going to do, I guess you could call it a wind tunnel test, but what I'm going to do is fix the sphere in space and then throw the wind at it. So there's always two ways of generating aerodynamic forces. You can keep something still and move the wind relative to it, or you can have the wind fixed and then move the object relative to it. And the equivalence principle in aerodynamics says it doesn't matter what you do, you get the same answer. So you could have a plane fixed in a wind tunnel with a 100-mile-an-hour wind at it, or you could have a plane with the air still, but the plane flying through the air at 100 miles an hour, and you get the same answer. So we're going to do the thing where we fix the object in space and then move the wind relative to it. So I could freeze the positions as a cheap way. If you just click on is kinematic, it just fixes it in space. So that's what we're going to use for now to make our kind of wind tunnel setup. Okay, let's give this a blow. Okay, let's click into empty space. So it's looking promising. We have got a wind arrow on the front here and a drag arrow on the back. And if we increase the wind speed, our blue wind arrow increases, but our red arrow increases even faster. And that's because drag depends on velocity squared. So that's good to see. And also, if we just check what happens if the wind comes from a different direction, that's correct, in that the drag is always opposite the wind. And the same works with elevation. Excellent, so that's all checked out. Quite often you find when you do this, you find you've forgotten to connect up a rigid body, or you've forgotten to put the arrows the wrong way around. It's much easier fixing these problems in a static situation than this, than your ball flying off to one side because it's not been set up right. Okay, so let's put this ball on the ground and see what happens when we release it. So that's our sphere, and we know it's 0.5 millimeters diameter, so that will just be sitting on the floor, and it is kinematic, so if we release that, it should move off on its own. And there we have it, it's trundling away. So if I change the azimuth of the wind, we've almost already made ourselves a little game where we can steer a ball just using the wind. Not too exciting, but increase the speed a bit. That's going up. And so on. But if you notice there that the orientation of the ball is moving completely, the aerodynamics is completely agnostic to the orientation of the body. The aerodynamics works on the shape, so Aerodynamic Objects handles all that all for you. So whatever orientation the body is, the aerodynamics will give you the correct answer. Okay, great. I'm just going to hide that. So that was making a sort of aero object from scratch. What I'm now going to show you is creating one from the Create menu, and it's kind of different style, but it shows you another way you can do it. So if we go to Aerodynamic Objects, Examples, Aero Object, Cuboid, and I'm just going to be clear about that, I'm going to call that Cube Aero Object. That's a bit on top of Aeroman there. Let's get it out of the way. And the thing you'll notice about this is, well, it's a cube, but instead of the ellipsoid mesh, it's actually got a kind of a rectangular mesh on here. So if we go dig down to where the aero body is, here it is. If we look at the geometry, the reference area shape is a rectangle. So when we're working with a cube, kind of the characteristic area is clearly a rectangle rather than an ellipse. So by default, this has got lift and drag. We could leave lift on. You don't get really any lift from a box, so it doesn't make any difference. So, but I am going to turn it off. And if we check the rigid body, so this one's already been set up, so it's actually linked already to the rigid body that's on this game component. So rigid body can be anywhere. It can be on the object. It can be somewhere else, but you need to make sure you link it up. We've got a box collider this time, so that's for the rigid body physics. So this will, when the box hits the ground, the box collider does the collision physics. We've got some graphics. Mass is the same. We've got a lift arrow. We don't need that, so I think I'm just going to get rid of it. We've got a drag arrow. Hasn't got an offset on it, so I'll put that in. And we don't have a wind arrow, so let's add a wind arrow. Put the offset the other way. Okay, and then I mentioned the equivalence principle in aerodynamics. So this time let's do it a different way around. So if we turn the wind off, and this time we're going to drop it, so its velocity is coming from its motion through the environment. There's no wind, but the flow experienced by this object is due to its own motion, and it shouldn't make any difference whether it's from the motion of the body or the motion of the air relative to the surroundings. The aerodynamics is agnostic to that. Okay, let's drop it. We've got everything set up. I've turned the wind off. Yeah, let's have a go. There we go, pretty quick. It dropped to the ground. You saw, I'll do it one more time, you saw the blue arrow underneath, so that's the wind facing the block as it comes down, and then the drag arrow was slowing it down. Okay, so since we're doing aerodynamic modeling, we have a proper model of this. If we now change the mass of this block, the drag coefficient will be the same for the same shape, but because the mass is less, it should fall at a slower speed. So let's go and change the mass. So if I do it by a factor of 10, so that's like a kind of light block of polystyrene. Okay, should have pressed stop. Let's do that again. Factor of 10, and let's release that. Okay, comes down more slowly. And you may have noticed we talked about the Unity physics engine has a drag model of sorts. With due respect to the physics engine, it's a kind of fake drag in that really all it is, it sets a terminal velocity for an object. So if you change the mass, it doesn't make any difference. If you change the size of the object, it doesn't make any difference. All it does is it just limits the maximum speed an object can get to. And similar with the angular drag, it kind of limits the rate at which an object can spin, which is great for adding in sort of fundamental things. Can't go too fast in a fluid, but as you can see from here, we can do a lot more of that when you have a real drag model. So if I make this bigger or smaller or change the wind, I get a different amount of drag. So it behaves intuitively as you would expect in a world with fluids and dynamics. Okay, that's good. So we've dropped the block. Now let's have a go at building a tower with it, because we should blow things down. So what I'm going to do is put it on the floor to start off with. So it's a 1 meter, so 0.5 is just on the floor. And the other thing I'm going to do, the default physics material is quite frictiony, so things don't slide very well. So what I'm going to do, if I just search for friction here, we've got a medium friction model which I'll put on, and that just means it kind of slides quite nicely. So we're on that. I'm going to do Control D for duplicate, hitting Control and make it go up, do it again, and do it one more time. So we made ourselves a little tower there. I'm doing Shift Select, and then I'm going to do Create Empty Parent. Let's just call that Tower. That's quite handy for moving the whole thing around. So we've got a tower of aerodynamic objects, and set the wind speed to 2 to start off with, and let's see what it does. And it blows it over. I have a funny feeling my mass didn't change. Yep. Okay, my bad. Let's change the mass back up to 1. The polystyrene blows over too easily. Okay, let's have another go. Okay, wobbled a bit, but we're safe. Okay, so we've got a tower with some wind blowing on it, and let's put a little bit of turbulence to make it a bit more exciting. And if I increase the speed, eventually it's going to blow the tower over. Okay, and because our wind, our uniform flow here is universal, it's global, it's everywhere, that will go forever. So I could speed that off and it'll shoot off over the edge into infinity. Okay, which is fine, but actually I think it would be nice if we could contain this flow. So imagine if we had a scene and we had some wind action happening in a box, but we didn't want that wind everywhere else in the scene. What we'd like to do is be able to contain that uniform flow within a box, and we do that by adding what's called a fluid volume to the simulation, and we do it up here. So if we go to our uniform flow, if we do add component fluid volume, and look closely at this small, it's a 1 meter cube that comes in. So at the moment that flow field is constrained to be in that 1 meter box, so it's not too useful for us. So let's make it bigger, and if we offset it by 5, have a look at it. So that box is actually the same box as we put our arrows in, so it's, well, coincidence, or we're just using the same shape box. But what's going to happen now is, because this fluid volume is on the same component as this uniform flow, it means that this uniform flow is going to be held within this volume. Equivalently, we could, as long as this was a child of this, it would still give the same effect. Okay, we got the settings correct on this. It's a box, whatever it is. We can look down here, flow primitives. When it's running, you can actually see if your fluid volume has found something in it. So it should find that it's got a uniform flow as part of it. Okay, let's give that a try. So if we go back to our tower, we've got our uniform flow. Okay, let's give this a run. So now if we blow the tower over, and if we try and push it out, eventually nothing more happens because we've blown out of the zone. So those arrows are getting bigger, but we've gone outside of the zone because our uniform flow is inside this box and it can't escape. Okay, let's get our tower, and we can sort of, a bit cheaty, but we can be better. Okay, that wind is far too strong. Let's put that back to 0 and drag it back in. Got my tower. Okay, they've moved miles away, but there we go. Stick them there. Our man's been squashed. But let's increase the flow again. But this time let's have some fun by changing the elevation. So if we make the flow go up now instead, put a bit of turbulence on, and increase that speed, we can eventually, so these kind of blocks are now in free fall and they're kind of floating in our wind, but because we've limited the size of the world, there they are, they've all sort of fallen off at the end. More turbulence. Okay, one more go. I'll just slide those back in. So what we've done there is boxed in our world using a fluid volume, and that gives you opportunity to do some interesting effects now, so that the fluid isn't uniform throughout the world. If you want something particular interesting to happen in a particular area, you can box it in and do it that way. So this tutorial really has been about introducing the idea of making an aerodynamic object, and we've seen 2 different ways of doing it. The first one was a composite approach, where we put different components on different game objects, and this is a great way when you start to help you define what each bit does. So the main thing is we have a rigid body, so that handles our rigid body dynamics. We have something that defines the geometry, the shape of the object, and then lastly you have this aero object component which defines the flow physics. You can put all of these on a single game object and it will work in a similar way. It's just a little bit harder to manage. Okay, so that's making an aerodynamic object, and that object had drag on. The next force in our arsenal is lift, and so what we're going to do in the next tutorial is develop an aero body with lift on it. So hopefully see you in that.